In section 1, we're going to talk about rectangular coordinates, graphing circles, and relations. So for your vocabulary, a relation is a correspondence between two sets. And so we use mapping notation and it's denoted for our example down here with a P arrow B. So the set P maps to the set B. And we can take this a little bit further and say that the domain is the set representing the independent variable. And so the range then is the set that represents the dependent variable. So if we use the sets down below, if you have a mapping of T to S, your domain would be the set T. And if we want to write it in set notation, that would be 1, 2, 3, 5, and 7. And then our range would be the S set since it comes after the arrow. So that would be 69, 85, 98, 123, and 145. So to graph, there are many ways to graph. One is to do a table of values. So if we plug in a -3 for the x squared, that would give us 4 minus 9, which is a negative number, and we can't take the square root of a negative without going into the complex realm. There's no real answer for y in that case. If we plug in -2 for x squared, that would give us 4 minus 4, which is 0. When you square root 0, you still get 0. Same with the negative, doesn't matter. If we plug in a -1, that would give us 4 minus 1, which is 3. So we'll have the negative square root of 3. If we plug in 0, that'd be 4 minus 0, and we know what the square root of 4 is, and with the negative on the outside would make it -2. When we plug a positive 1 in, since we're squaring it, the positive 1, 2, and 3 are going to yield the same results as the negative 1, 2, and 3. So we'll have negative square root of 3, 0, and if we plug in a 3, it'll give us a non-real answer. So if we graph these and count every other block as a whole number, then at -2, we're at 0, so sitting on the x-axis. At 1, we are at the square root of 3, which is a little more than 1.5 here. And then at 0, we're at -2. And then we're going to mirror that on the right-hand side, since the positives are the same as the negative. So it gives us roughly a half circle for that graph. And so finally, a graph is said to be continuous if the entire graph can be drawn without lifting your pencil from the paper.